I'm Binuka Kamesh. My final year research project is real-time guitar chords recognition system. So the main motivation is one of the challenges for someone playing any instrument is to reproduce a song that they enjoy listening to. If the individual doesn't have the sheet music for that song, and if they can't learn that play, if they can't play the song just by listening to it and reproducing the notes, one of the tools they have to see is someone is see how someone's playing that song and try to mimic their playing. Another scenario is where computer generated musical transcription would help occurs when a musician needs to transcribe a piece of a lesson, like piece of a sheet lesson, like if, when you are watching a YouTube guitar playing tutorial, like if you want to learn that part, you can there's no way of learning that guitar chord without the transcription for the and also when you're writing when you're composing the music, it's also the same. So my intent with this project is to build an application which will recognize guitar chords as someone plays a song in front of you by pointing the camera towards the hands of the artist or the guitar player and annotate the chords as someone playing them. So the that's main uh, intention of the project. So the problem background is finding the chords of the specific song is always a difficult task. Even though many musical transcriptions are available over the internet, they are not always accurate, and the newer songs are not always presented. Another problem is when someone playing the guitar, watching a guitar playing tutorial, is to reproduce that the chords that the artist playing. uh, they have to if they don't have the transcription, they have to learn by themselves. So when considering the live musical shows, also the same, most of the time the artists are not playing their songs in their original chords notations, and they are not playing in their original song scale. So in that scenario, there's a problem in reproducing the actual musical chord sequences. So the another problem is when the artists try to compose some piece of music, they what they do is mainly they grab piece of sheet uh, and they are writing the chords as along while they are playing the guitar, uh, and put chords in their notation sheets. So when the artist try to compose some piece of music, they play the guitar manually, write down the chords that comes to their mind with a pen. It's always been a difficult task, and the productivity of that thing is very low, because if they got because they are composing music lively, so if they forgot the previous chords that came to their mind, there's no way of getting the chords. So the proposed solution will the application will ask from the user to turn on their camera. It captures the video footage and the audio feed from the user, and it instantly predict the guitar chords while you're playing the guitar. uh, the system will pre-process the data from the gathered by the user, and also they will be trained using pre-trained model. The whole proposed system will be based on the state of the art convolutional neural networks. This is the high level design of the system, and as you can see from here, they are this is tree tier architecture diagram. The data tier, the logical tier, and the presentation tier. So the approach is, for a standard tune electrical guitar, major chords can be recognized visually just by looking at the position of the player's fingers. This means that the given chord, the position of of the player's fingers in the neck, provide hints about the chord that the being played. As an example, the fingers, as you can see from in this image, the way fingers are positioned in the neck for the D chord. This is the D major chord. uh, so you can, if you have basic knowledge about the guitars, you as you can instantly, when you see this hand shape, you can recognize the chord, like this is the D chord. So if someone understands the shapes of the guitar chords, glances at someone that playing that chord, this person will recognize the chord even without hearing it. Like by looking at this image, you can instantly tell this is the D chord if you know about guitar. The scope of this program is to recognize basic popular shape of major chords in guitars to prove the concept. By training a classifier with hundreds of thousands of images of each chord, my intent is to recognize in real time that the chord that the artist is playing. Uh, so the result was successfully achieved after extensive training of a classifier and using optimal choice of training epochs, source data, and the best performing optimizer. The implementation details I'll start demonstrating in a little bit. My initial solution uses Python and was implemented in using Jupyter Notebook, and my original plan was to capture in feed a lot of data to the uh, pre-trained model. And after some research, I realized that with some with the controlled environment, I implemented two different ways of inputting data to the system. The one is it can get generate data set from the user also. So the plan is to capture 250 images of for each chord, resulting 2000 pictures in total for all the 7 major chords. And for the capture, to capture 2000 pictures with the same basic scene with the same lighting conditions, and I applied. I simply iterate through a for loop 250 times for a single chord, and it takes approximately 8 pictures per second. uh, to control the frame rate of the snapshot, I used time to sleep while the program captured the frames. And while capturing the images, I moved my hands slightly left and right, up and down, to make it more diverse data set. And the current progress and the future plan of the project. So currently, approximately 70% of the documentation has been completed of the final thesis. So the chord recognition using the video footage part of the project was completed with some good amount of accuracy, but it needs some more data to train. So and also the code recognition using audio data needs to be completed, and it should be able to combine both audio and or video data for the prediction. And also the front end development of the project, and the front end back end connection, the server side part needs to be completed. uh, the main plan is to complete the core feature part core feature and the front end part by the end of March. The final prototype will be completed by the end of March, along with the testings, and evaluation will be done during the first weeks of April, and we'll get the supervisor feedback and completed within the month of April.